Hey class, this is Mr. Schmidt for our February 11th Zoom meeting. So those of you who stick around to the very end had some questions, and for the first time this year, my Zoom just turned off. Just in the middle of a sentence, I was talking, and all of a sudden the whole thing blinked off. I couldn't get back up. I'm sorry for that. I will keep taking questions versus email and class beginning of next week when weather allows, when we're allowed to come back to school. So this turns out to be a great week to be discussing weather as we have it impacting a lot of our lives coming up here. So the first thing we want to know is how will they know the weather tomorrow? It's been a big discussion. There's supposed to be snow coming. And the answer is they look at both the surface winds and the jet stream, and they look at where things are going. And so if you use the radar to look at inside the clouds and to track its direction and the density of particles inside the clouds, you can see there's this wave of content coming towards us. And we can also look downwind or upwind rather, and look at those temperatures, and we see that it's cold, there's moisture. That combination is going to leave us with a pretty good chance of snow coming soon, and there's another band of snow that's supposed to come in later. If we look at this, we'll have one set of snow coming in through Friday morning, so 1 to 2 inches at the Portland airport, and then another, 3 to 4 inches at the Portland airport, and then another 6 to 8 inches Friday evening through Saturday. So they're making these predictions based on the stuff we're looking at, the air masses, the humidity, the temperature, all that's coming into play. Okay, so that answers our first question is how do they know tomorrow's weather? They're tracking the winds and the temperature and the humidity and the pressure, and they can compare that to other times they've seen it, and they can make a decent prediction. Okay, now the better they can do at measuring these points, the more mathematical their models are, the better they can do at the prediction. But just knowing math doesn't necessarily get us to the answer. Okay, so that means there is watches and advisories in effect for Vancouver and Portland. By the time you watch this video, maybe not as important, but it was super relevant to today's lesson. Okay, what we're more concerned about in terms of our assignment is being able to discuss the underlying properties of weather patterns and clouds. So the last week or so, we've been talking about definitions and what things are. Today, we want to start talking about the how and the why of weather and what causes the weather and how can we predict the weather. Okay, so there's lots of different types of clouds, and we'll look at those. But if we're talking about weather and the weather conditions on Earth's surface where we live, we're going to want to look at where is there precipitation, the rain, the snow, that kind of stuff. So we'll have cumulus clouds, which will be puffy clouds, like the cotton ball type clouds. That has a decent level of moisture inside the clouds and can cause brief periods of rain. Okay, so we see theirs fairly often. What we see even more often are the stratus type clouds, which are long and flat, and they form many layers, and they have gentle rising air, which means just long, steady rains, which feels like the Portland, Vancouver weather as you just look out over the horizon and all you see is clouds, and it just keeps raining and raining and raining as all that moisture coming off of the Pacific hits colder air coming off of the north or off of the mountains, and the rain just slowly comes down more and more. Okay, so we can look at different types of clouds. So these are the two big ones in terms of precipitation, but we can see that there are many types of clouds here. So this gives us a good sense of where are the clouds at the very top of the stratosphere, what are the clouds in the middle of the stratosphere, And notice when we see certain types of clouds, we can start making predictions about what type of air mass caused that cloud, and therefore what kind of weather is about to occur. Okay, so when we see these altostratus or nimbulostratus clouds coming over the horizon, we know it's going to happen. Okay, and like I said, Portland, Vancouver, talk about description of what we see so often as those stratus clouds. You can't see the mountains, you can't see across Portland, you just see these very low-lying clouds, not necessarily a rainy day, but just a very low-lying fog-like cloud right above the city. Okay, so again, so we see those puffy clouds, cumulus clouds. There may be enough to form rain, but normally they're just beginnings. Okay, these are the ones you really have to worry about, the cumulonimbus clouds. They start very low and they go very high, and they can form all different types of violent weather. Okay, so as you get into today's assignment, if I jump up to today's, that's not an assignment. If I jump to today's assignment, we get kind of poorly drawn clouds. And you're never going to find an exact picture that matches the one you have, unless you did like a Google search, you found the picture they used. But the fact is, day after day, if you take pictures of clouds, you're not going to get carbon copy duplicates. You're going to get similar properties that form similar clouds. And we try to figure out what's going to match the picture closest. So if we're looking at fluffy clouds here, like at number 3, then if we come back, okay, well, is that more stratocumulus or is that more cumulus? Well, we're going to have to start making judgment calls about how much gray is in there, how dark it is, does it have a honeycomb-like appearance? We start to put pieces together, okay? The better the picture, the better you'll be able to make predictions. And these were intentionally bad pictures to give you kind of a range of possibilities, and I'll take a range of answers. Now, if you see rain coming out of the clouds, that kind of gives you another clue into what we can do in today's assignment. But again, we're going to look back at these clouds, okay? Especially the most common ones. You can scroll down, you can keep seeing some of the more interesting special clouds as it goes, okay? But that's not even a thorough list there. You can get more types of clouds. And if you go to other textbooks and other websites, you're going to see even different kinds of categorizations of clouds. Meteorologists keep trying to sort them into more and more specific categories to be more accurate in their predictions of the weather and of climate. Okay, so obviously I'm not going to go into all of these, but the idea is there's just a lot of different categories, and each one gives us another data point about precipitation, wind, temperature. All of those are held here in the clouds. Something happened that caused this cloud to form, and that tells us what is coming or what is present that caused that cloud formation. Okay, so those cumulonimbus clouds I showed earlier, those are ones we often talk about because they cause thunderstorms. They're warm temperatures, caused moisture to come out of the water or the plants, and they cause them to come up, which creates great pressure changes, creates updrafts, creates lightning and thunder, and it can create tornadoes. Okay, so if we look at some of those, we can see what different universities have to say about this. It's University of Carlson. Okay, and again, you know, we want to look at what are the clues. So before this happens, you can see the cloud, say, oh, that's bad. Let's get out of the swimming pool. Let's get off the soccer field. Let's get away from the softball. Okay, let's go inside because we're seeing certain clouds that are known to have dangerous weather. Okay. So we've talked about some of these air masses before. air coming off of the ocean tends to have a lot of moisture. Air coming off of a continent tends to be dry. If it comes from the north or from the poles, it tends to be cold. So we can start tracking these temperature and humidity facts here. And we put that together with a jet stream, which is not a perfectly straight line. It does wander around. And as Earth's orbit moves around the sun, it's going to cause those winds to shift. And as the pressure fronts move through, it's also going to cause these jet streams to shift. Okay, so it's not going to be any one definitive jet stream map, but it does give us certain ideas about what's going to happen here. Okay, so what are we seeing in Vancouver today? We're seeing a cold air mass arrive. Okay, and as the cold air comes in, the warm air is forced up. Okay, and then we get all of that moisture that was in the clouds is going to fall through the cold air, stay snow, and hit us. Okay, warm fronts are much more gentle, and we've been seeing kind of a large warm air mass over our city for a while now. For Vancouver in January and February, we've had a very mild winter as this warm air just kind of stayed in place around the Portland Valley here. So we can look at our next link here. If we are thinking about cold air masses, the way we can figure that out without actually being in the clouds and measuring all the clouds is they have weather stations. Okay, so airports are a great place to check the weather because they are super concerned about the weather, and they have great weather stations. So you can look at the weather report at every airport, and you can see there are some places that are warm, and even though this is similar altitude, similar latitude, we see a drop in temperature. So that means there must have been a cold front moving past it, and we expect that cold front to keep moving as we see the changes in temperature. Okay, and then we can make more predictions about what's happening and where the clouds are going to increase and what kinds of clouds they are. Okay, all based on this tracking of surface temperatures. Okay, and then as we look at clouds, I'm not going to play the video here, but there is a YouTube video you should watch. As moisture rises through the troposphere into the tropopause, we see different things happening as it crosses a temperature barrier going through the troposphere, and it's cold enough to condense. And then if you hit the very top of the troposphere, that's when you get the cumulonimbus clouds spread out, and they have what they call this anvil shape. Okay, so like I said, I'm not going to show that video, but there is a YouTube video about that. Okay, and then the other thing we need to know for the assignment is about humidity. So you can have relative humidity, which is what we've been talking about, which is the percent of moisture that the air could hold. And that is what we normally care about in terms of how do we feel in this room when we walk outside, what is the relative humidity. But if we're looking at clouds, we want to know what is the absolute amount of moisture in that cloud or in that patch of air, and that is going to be its absolute humidity. So cold air can hold less than warm air. So there's going to be different levels in terms of how much it could possibly hold. But in terms of like finding out how much snow we're going to get, we want to know the absolute humidity, the absolute amount of moisture present in the air. Okay. So that hopefully sets you up for the assignment. I will tell you these pictures are not perfect, so you do have to go through those websites and just make your best guess. And once you've made your guess, you take down what did that tell you based on the type of cloud it is. Okay, and then on this one, you actually are better off looking at our old assignment or our old notes from the beginning of the week. As you see the different types of fronts collide, very specific types of clouds are going to form. And that should help you with this assignment here. So when they ask the kind of precipitation and the kinds of clouds, that is going to all go back to last week's or Monday's notes. Okay. So with that, I'll see you guys later. Enjoy whatever weather we have coming, and I hope to hear all sorts of interesting stories of your weather experiences come next week. See ya.